In this video, we'll be looking at 5.6, Solving Polynomial Equations. Number of solutions theorem. This number of solutions theorem is very close to what's called the fundamental theorem of algebra. Fundamental theorem of algebra. And that sounds like a big deal, doesn't it? It says if p of x is an nth degree polynomial, then the polynomial equation p of x equals 0 has exactly n solutions, some of which may be repeated solutions. All of the solutions will be complex numbers. That means it can have an I with it, all right, or it could be just a real number. It can have an imaginary portion, and some of them may also be real numbers. All right, so in your notes, I would include just this first portion. Some polynomial p of x that's to some power n, the leading, it will have exactly n solutions. For example, if we have f of x equal x to the 5th minus 4x to the 4th plus 2x squared plus 7, and we set this equation equal to 0, all right? We say this is equal to 0. This equation will have 5 solutions. Now, some of these solutions may be real numbers. Some of them will be complex solutions, that is, have an I involved in it. One of them might be what's called a double root. That is, it is a repeated solution. But this leading power tells you how many solutions the equation has. Next, Descartes' rule of signs. Let p of x be a polynomial equation with real coefficients. So we have some polynomial set equal to 0, and it has real coefficients. 1. The number of positive real solutions is either equal to the number of variations in the sign of p of x, or is less than the number of variations in the sign of p of x by a positive even number. The number of negative real solutions is either equal to the sign variations in p of negative x, or is less than the number of variations in the sign of p of negative x by a positive even number. All right, that's a mouthful. You'll need to include this entire statement in your notes. And let's look at an example. What can we say about the real solutions to the polynomial equation? Well, based on what we saw first, there's going to be 5 solutions. Now, some of these may be real, some of them may be complex. We may have a repeated solution, but there will be 5 solutions. All right, I'm first going to look at this number 1. This is the number of positive real solutions. Okay. I'm just going to examine the sign changes of my polynomial here. Well, initially we're a positive. Then it goes from positive to negative. That is one sign change, 1. Then it goes from negative to positive. That is my second sign change. Then it goes from positive to negative. That's my third sign change. Then negative back to positive. That's the 4th sign change, and then positive back to negative. You can see there are 5 sign changes here. Since there are 5 sign changes, I can have that many positive real solutions or less than that number by a positive even number. So Thus, there will be 5 or 3 or 1 positive real solutions. However many sign changes there are, the total number of sign changes, it'll be at most that, and then decreasing by 2 all the way down. All right, we won't say -1 positive real solutions. All right, number 2. Now we're going to look at the number of negative. Number 2. Number of negative real solutions. To find that, we must first evaluate p of negative x. Well, p of x is this, p of negative x. P of negative x, I'm going to substitute negative x every place I see an x. This will equal 4 times negative x to the 5th minus 3 times negative x to the 4th plus 2 times negative x to the 3rd minus 2 times x squared, negative x quantity squared, plus 3 times negative x minus 4. All right, so now we'll simplify this expression. Well, negative x to the 5th will be negative 4 x to the 5th. That is, if we take negative x to the 5th, that returns negative x to the 5th, and negative times this positive is a negative there. Minus negative x to the 4th power, well, negative x times negative x times negative x times negative x, that's going to return a positive x to the 4th. Well, positive x to the 4th times negative 3 is a negative 3x to the 4th. Plus, when we have this negative to an odd power, it's going to remain negative. Times this positive 2 makes us a negative 2x to the 3rd. It's minus 2x to the 3rd. Negative x quantity squared becomes x squared. Times minus 2 will be a minus 2x squared. 3 times negative x will be a negative 3. And then minus 4. Alright, now we will look at the number of sign changes. It begins negative and it stays negative. No sign change. Negative to negative, no sign change. Negative to negative, no sign change. No sign changes here. It remains negative throughout. Thus, there are 0 sign changes. Thus, there will be no negative real solutions. If the rational number p divided q is a solution to the polynomial equation, this polynomial equation, where the coefficients a0 through an, this constant all the way through this leading coefficient are integers, that is positive or negative whole numbers, then p is a factor of the constant term, p will be a factor of this one, and q will be a factor of this one. Okay. What this is saying is, if we have some polynomial in this form, we can get an idea of what the solutions are by looking at the factors of this number and the factors of this number here. All right. The factors of this number, this is our a sub n. We're going to call those q. Okay. The factors of a sub n we're going to call q. So in this case, our a sub n is equal to 2. And the factors of 2 the factors of 2 are 2 and 1. 2 times 1 multiplied to give 2. And typically we only talk about the positive factors, but here it's going to be necessary to talk about the negative ones as well. So we'll say plus and minus 2, plus and minus 1. These are our values Q. Q is a factor of the leading coefficient A sub n. These are our possible Q's. 2 and 1, plus and minus both of them. Now we're looking at our A sub 0, or A naught. Well, A naught is our constant, this number 6. We want the factors of 6. Well, 6 is clearly 1 times 6, right? Again, it can be positive or negative. And 6 is also 2 times 3. Plus and minus 2, plus and minus 3. Well, here's what this thing is telling us. And this A naught, P is a factor of A naught. So these numbers here are our possible values P. So any solutions to this equation will be of the form P divided by Q. So P divide Q. We're going to take all these numbers and divide by these. Wow. That's quite a few numbers. All right. So it could be plus or minus 1 divided by this plus or minus 2. Now I don't have to repeat the plus and minus on both of them because we would accomodate this. We would accomplish the same thing. That is, I will say plus and minus 1 divide 2. To say positive 1 divide positive 2 is the same as saying negative 1 divide negative 2, and we don't have to write plus and minus for both of these. Okay, that is this P divide this Q. Now I want this P divide this Q, so plus and minus 1 divide 1. Next, P divide Q, plus and minus 6 divide 2. Then plus and minus 6 divide 1. Again, I'm taking, it says P divide Q. These are my P's. I'm taking all of these P's and dividing by these particular Q's. All right. Now 2 plus and minus 2 divide 2. Then plus and minus 2 divide 1. Lastly, 3. Plus and minus 3 divide 2. Plus and minus 3 divide 1. All right, that's quite a lot of numbers. First, make sure we have the right number. We have 4 of them here and 2 of them here. There should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Are all of these value solutions? No, but the real solutions will be amongst those. So these are giving us potential numbers to try out. First, we can do some reducing here. 1/2, there are no other 1/2, so we could have plus and minus 1/2. This is 1. Well, so is this, 2 divided by 2. Okay, so I don't have to repeat that. Plus and minus 1. Okay, well, 6 divided by 2, that's 3. But so is this, 3 divided 1. So plus and minus 3. All right, 6 divided by 1, that's 6. 2 divided by 1, that's 2. And 3 divided by 2, that's 1.5. So we've reduced a few, but we still have many to try from. 1, 2, 3, 4, 5, 6. Plus and minus each one of those, that's 12 possible numbers. So what we're going to need to do now is substitute these numbers one at a time into our equation. And once we find one that satisfies it, then we can use methods that we used in the previous section to find others. So I'm going to take any of these numbers and substitute in here and see if it satisfies it. Let's use MetaCalculator. All right, so I'm taking the equation 2x cubed minus 3x squared minus 5x plus 6. Going to meta calculator. So instead of 0, I'm replacing it with y. 2x to the third minus 3x quantity squared minus 5x plus 6. All right. Now I'm simply going to come to my table because this will help me look very quickly. I'm looking for the zeros. I'm looking for the values that pair with 0, but I know I have some possibilities to narrow it down to. I want plus and minus 1. Let's look for that. When x is 1, y is 0. I have it right there. Here's another one. When x is 2, y is 0. All right, so going back to my, I see positive 1 and positive 2s on my list. So I already have 2 such factors. Now I only need to find 1 more. So in this case, we've already nailed 2 of our factors. We just need to find the last one. All right. So we have just verified that x equal 1 and 2 are solutions. Thus, x minus 1, the opposite of that, and x minus 2 are factors. So we could divide by our original polynomial by either one of those to find that final factor. Let's say that we only had this x minus 2. So I'm going to take my polynomial, 2x cubed minus 3x squared minus 5x plus 6, and I'm going to divide by x minus 1. X goes into 2x cubed, 2x squared times 2x times x is a 2x cubed. 2x times minus 1 is a minus 2x squared. Change, add. This becomes negative x squared minus 5x. X goes into negative x squared, negative x times this is a negative x squared. Negative times negative is a plus x. Change, negative 5x and negative 1x is negative 6x. Bringing down my plus 6. X goes into negative 6x minus 6 times. Negative 6 times this is a negative 6x. Negative times negative is a plus, and you can see that does indeed give a remainder of 0. So this is my other factor. And I know that x minus 2 is a factor of this. Thus, I'm going to factor this. 2x squared minus x minus 6 equals, well, I have this factor. And I just need one other one. Well, this one will make this much easier. X times what gives 2x squared? 2x. Negative 2 times what is minus 6? Minus, or plus 3. Negative 2 times 2x will be a negative 4x. Positive 3x, that gives that negative x in the middle. So now I have my 3 factors. X minus 1, x minus 2, and 2x plus 3. So we already knew that we had 1 and 2. This is my last one. Thus, 2x plus 3 equals 0, subtracting 3 on both sides. 2x is minus 3, dividing by 2. X is negative 3 over 2. And that, indeed, was one of our possible answers, negative 1.5. So those are our 3 solutions, 1, 2, and negative 3 over 2. So to use this rational solution theorem simply generates a list of possible solutions. From there, we're just going to try them out. Once we have one, then we can do some division to find the others. And that concludes this video.